Now let's go to another part of our topic, the differentiation rules. Differentiation rules is very important to help us to solve the derivative of a function very quickly. Without this, we would need to solve the derivative of a function through the lengthy process of getting the derivative through the definition of the alternative equation. Now let's take one at a time the different rules of differentiation. The first rule is the constant function rule. So the graph of a constant function is a horizontal line, and a horizontal line has a zero slope. Therefore, the derivative measures the slope of the tangent, and so the derivative is zero. The rule number one, the constant rule. If f of x is equal to c, where c is a constant, then the derivative of that function is equal to 0. Again, the derivative of a constant is equal to 0. Take for example, the f of x is equal to 10. 10 is a constant, therefore the derivative of that function is equal to 0. Another one, h of x is equal to negative square root of 3. Negative square root of 3 is a constant, therefore the derivative of negative square root of 3 is equal to 0. And lastly, the g of x is equal to 5 pi. Pi has a value, which is a constant. So therefore, the derivative of 5 pi is equal to 0. So before I will lead you to the power rule, let's check the power function. So a function of the form f of x is equal to x raised to the k, where k is a real number, is called a power function. So below are some examples of power functions. So the f of x is equal to x is a power function because the exponent is equal to 1. So this is the power function. The g of x is equal to x squared is another power function because obviously the exponent is equal to 2. While the h of x, it may look like a radical function, but we could convert it to a power function which is equivalent to x raised to 1/2. And so therefore, for the exemplar D, p of x is equal to the fourth root of x. This is also convertible to the power function x raised to 1/4. For the fifth example, L of x is equal to x raised to negative 5. This is a power function with an exponent equal to negative 5. And lastly, S of x is equal to 1 over x raised to 8 is another, it's a rational function, but you can convert it to a power function by this one, x raised to negative 8. So it means you switch the denominator to the numerator and you change the sign of the exponent, so from positive to negative. So these are the examples of a power function that is very useful, and it could be used for as we apply the power rule. According to the power rule, the f of x is equal to x raised to n, where n is an element of a natural number. Then the derivative of that function is equal to the n, or the exponent, times x, that's 1, raised to n minus 1. So this is the power rule. For an example, if f of x is equal to x cubed, then according to the power rule, so the exponent becomes the coefficient, and then the exponent minus 1, so 3 minus 1, so it becomes 3x squared. Number 2, we will find the g prime of x, where g of x is equal to 1 over x squared. So this is a rational function. So in order to use the power rule, we need to convert it into a power function. So 1 over x squared, to become a power function, it becomes x raised to negative 2. And we will apply the power rule to x raised to negative 2. Now the negative 2 will become the coefficient, and then negative 2 minus 1, that's negative 3. So the answer is negative 2x raised to negative 3. That's equivalent to negative 2 over x cubed. And lastly, find h prime of x, where h of x is equal to the square root of x. This is a radical function, so we need to convert it into a power function before we could use the power rule. So the square root of x is equivalent to x raised to 1/2. So the derivative of the 1/2, so 1/2 is the exponent, so you will use it as your coefficient, so 1/2 x, and then 1/2 minus 1 according to the power rule, so that's negative 1/2. So 1/2 x raised to negative 1/2, that's equivalent to 1 over 2 square root of x. Another very useful rule, the constant multiple rule. If f of x is equal to k times h of x, where k is a constant, then the f prime of x, or the derivative of that function, is equal to k times the derivative of h of x, or the h prime of x. Take for example, f of x is equal to 5x raised to the 3/4. So there is a constant here which is equal to 5, and we know how to solve this, right? Because we have the power rule, so we will just use the power rule and the constant multiple rule simultaneously. So according to power rule, so the 3/4 becomes here times the constant here, so 3/4 times 5, that's 15 over 4. And according to the power rule, we will subtract 1 to our exponent. So 3/4 minus 1, that's negative 1/4. So 15 over 4 x raised to negative 1/4 is the answer, or that's equivalent to 15 over 4 times the fourth root of x. Second example, the g of x here is 1/3 times the cube root of x. So we have a constant here, 1/3, and we will use the power function again to solve the derivative. But first, we have to convert this into a power function. So that's equivalent to x raised to 1/3. And then we have a constant here, so we will multiply that according to the power rule. We will multiply the exponent, and then according to the constant multiple rule, we will multiply it to the constant. So 1/3 times 1/3, that's equivalent to 1 over 9. And then 1/3 minus 1, that's negative 2/3. So 1 over 9, x raised to negative 2/3, or that's equivalent to 1 over 9 times the cube root of x squared. And the last example is h of x is equal to negative square root of 3x. So the derivative for that, the h prime of x is equal to, this is 1 exponent, so 1 times the constant here, which is negative square root of 3x, and then 1 minus 1 is 0, so x raised to 0 is equal to 1, times the 1 here, so it's still 1, times the negative square root of 3, so that's negative square root of 3, and that's the answer.